Class 9, Chapter 3, Algebra. Algebraic expression. Here we are going to see the first algebraic expression. An algebraic expression is a combination of constant and variable combined together with the help of the four fundamental signs. First of all, we want to know what is the variable and constant. Constants means which has a fixed numerical value, as a fixed numerical values, right? All the real values are a constant value. All the real values are the constant value. -5, 2, √3, right? 0.5. These are the constant values. And then variables having the various numerical value. Variable have various numerical value. The variable has a various numerical values, so it is not a fixed numerical value. It will be denoted in the form of alphabetic small ABCD to Z. Alphabetic in that small ABCD, right? We have to denote in the form of small letter, either X, Y, Z or P, Q, R. These are the variables, right? Now we see what is the coefficient of the form. Coefficient is a multiplying by the variables of the term. Multiplying the part of a term multiplied by the variable. First we have to see that what is the algebraic expression. In that algebraic expression means combination of both the constant and variable. Suppose I take the algebraic expression as like this: 4x square plus 8x minus 1. It is a algebraic expression, but by the four fundamental operation: addition, subtraction and multiplication, division, right? We used to write this in the form, so it is called a algebraic expression. In this algebraic expression, the algebraic expression is always in the combination of constant and variables with either an addition or subtraction or multiplication and division symbol. Now we want to know the coefficient. The coefficient of x square, this part is multiplied with x square, so the coefficient of x square is 4. Coefficient of x square is 4. What is the coefficient of x? The coefficient of x is 8. Suppose in case here we have 4x square y plus 6x minus 1 like this. Here what is the coefficient of x square means the multiplying product of x square with what number is standing with that x square, that is multiplied with x square is the coefficient. Here in the second term the coefficient of x square is 4 and then y, 4y. The coefficient of x is 6, right? This is the coefficient. Next topic is here polynomial. Polynomial in one variable. First of all, the polynomials are denoted by in the form of p of x or q of x or r of x, f of x and then g of x. These are the notation of mentioning the polynomial. Either we can use here x or y or t or z, whatever may be, right? P of x is the polynomial. The polynomial is mentioned like this in this form. Here polynomial in one variable means the term having single variable, that is ax square plus bx plus c. See, here we have that x is the variable and a, b, c are the constant values, right? In general, we use like this: ax square plus bx plus c is the term. For example, 4x square plus 6x minus 1. So here we have x, here also we have x. So single variable, polynomial in one variable. The power may be whatever may be differ, but the variable must be same. This is called a polynomial in a one variable. And then the polynomial is always in this form. The variable having the power with whole number, either 0. Here x power 0 is equal to, what you get? X power 0 is equal to value 1. So 1 into 1 is, we get 1. That is a constant term. In constant term, we have the variable's power 0. So we know that any number having the power 0 is equal to value 1 is the term. And then the polynomial is always in that form. The variables having the whole number, and then the variable did not be in the denominator. This is a polynomial. It is not a polynomial because the variables having in the denominator. If the variable having in the denominator means that is 1 by x square, I take this x square to the numerator means we get the power as negative, x power minus 2. So non-negative value, so it is a negative, so it is not a polynomial. So the first condition, the variable should not be in the denominator, and then non-negative, right? Either this or this. It is the non-negative value. If it is in a negative, the power having negative value means the given algebraic expression is not a polynomial. It is in the denominator, so it is also not a polynomial. Suppose 4 root x. We know the value of root, square root x, right? Value of root x is equal to, root is equal to 1 by 2, right? It can be written as in the form of x power 1 by 2. And then the variable's power should not be in fraction. The variable's power should not be, either we say it is in a root value, that is a surd value, right? We call it surd, or root value, either in what power, cube root of x or square root of x, whatever may be. The variable's power should not be in a fraction. So this is also not a polynomial. So if you say that it is a polynomial means the polynomial must be in the standard form, either in a ascending order or in a descending order. This can be written like this: minus 1 plus 6x plus 4x square. This is also a algebraic expression. This is also a polynomial in a standard form. Either the variable's power must be increasing order or in a decreasing order. These two are called a standard form of the polynomial. The polynomial must be always, the power must be in the whole number, either it is except 0, 1, 2, right? If it is, there is no number, that is 1. The variable should not be in denominator, and then the variable's power is always non-negative. So, and then the variable should not be in a root value, right? Root is a fractional. So these types are called not a polynomial. Suppose if I take x power 3 plus root x plus x power 1 by 2, 8, 7 like this. Is it a polynomial? Clearly it is having a root value, so it is not polynomial. Another one, it has a power of fractional, so it is not a polynomial. And then next one, x cube plus 3 divided by x square plus x. Here x square is in the denominator form. In the denominator I take it to the numerator means we get x cube plus 3 x power minus 2 plus x. So it is not a polynomial. These all are not a polynomial. So the polynomial means always in the standard form. The standard form is either in ascending order or in a descending order. Ascending order, descending order means the power of the variable. The power of the variable is, see here, x power naught, x power 1 and then x power 2, increasing order. Here x square, x power 1 and then x naught, decreasing order. So this is called the standard form of the polynomial. Next we see the degree of the polynomial. See, in this polynomial 4x square plus 6x minus 1. See, highest power is the degree of the polynomial. Here highest power is 2. So, in this polynomial, degree of the polynomial is 2. Right? And then suppose 4x square y z plus 6x square y plus 7z. Like this means you have here 3 variables, right? Here we have 3 variables. The 3 variables power should be added. Here we have 2, here we have 1, here we have 1. So 2 plus 1 is equal to 4. Here we have the power 4, here we have the power 3. So here we have the power 1. Now the degree of the polynomial is 4 for this polynomial. The degree of this polynomial is 4. The highest power should be, each and every variable's power should be added, either it is in the product form. So it is a separate term. This is the first term, this is the second term, and then this is the third term. Separate terms, right? So if it is a separate terms, means we don't want to add the powers. In a single term, in a only one term, whatever the variables having, that variable's power should be, you have to add. This is the degree of the polynomial. The highest power of the variable is the degree of the polynomial. And here 0 of the polynomial, 0 of polynomial is not definable. 0 of the polynomial is not definable. That is g of t is equal to 0 into t power 4 plus 0 t square minus 0 t. Each and every term has 0. It is not able to define the term. It is not able to define. So the 0 of the polynomial is not defined. 0 of the polynomial is not defined. How the degree? We cannot be able to find the degree of this polynomial. So the degree of the polynomial is not defined. Thank you, students.